Hello children, welcome back to the physical science class. In this session, we are going to learn about classification of magnets and the difference between natural and artificial magnets. In Unit 7, Magnetism. Come, let's go through the lesson. Magnets are objects of stone, metal, or other material which have the property of attracting metals like iron, cobalt, and nickel. The attracting property of a magnet is called magnetism, and it is either natural or induced. The branch of physics which deals with the property of a magnet is called magnetism. The earliest evidence for magnets are found in a region of Asia Minor called Magnesia. The directive property of magnets has been used for centuries to find directions. Around 800 years ago, the Chinese discovered that a suspended lodestone stops in the north south direction. Chinese used these lodestones to find directions. The navigators of that country used to keep a piece of lodestone suspended in their boats, and during a storm or mist, they used the lodestone to locate directions. It is believed that the Chinese had known the property of magnet even before 200 BC. They used a magnetic compass for navigation in 1200 AD. Use of magnets in compasses facilitated long distance sailing. After the discovery of magnets, the world progressed into a new direction. Today, magnets play an important role in our lives. Magnets are used in refrigerators, computers, car engines, elevators, and many other devices. A magnet is an object which attracts things made of iron, steel, nickel, and cobalt. Magnets are interesting substances that can attract certain materials like iron, cobalt, and nickel. Now, I tell you a story behind the discovery of magnets. Magnets were discovered by a Greek shepherd named Magnus. One day, while grazing his sheep, Magnus found that the iron tip of his walking stick got stuck on a rock. On checking carefully, he found that the rock had a strange property of attracting anything made of iron. This rock, which came to be known as magnetite, was a type of magnet. Magnetite is an oxide of iron. When pieces of magnetite are freely suspended on a thread, they all point in the same direction as north south. In ancient times, the freely suspended magnetite were used by sailors in the ships to find direction. Since magnetite was used to lead the way for ships, it was known as lodestones or leading stones. It was believed that the Chinese people were the first one to use lodestones as indicators of direction. A magnet is a substance that has the property of attracting certain materials. The force that causes magnetic materials to either attract or repel each other is called magnetism. Magnets are classified into two types. They are natural magnets and artificial magnets. Some materials that occur in nature are magnetic. These substances are called natural magnets. Magnets found in the nature are called natural magnets. These magnets are found in different places of the earth in the sandy deposits. Lodestone, called magnetite, which is the ore of iron, is the strongest natural magnet. Natural magnets do not have a definite shape. Natural magnets have irregular shapes. The strength of a natural magnet is well determined and difficult to change. Natural magnets have less usage. Natural magnets generally have a weak power of attraction. Magnetite is an example of a natural magnet. Minerals like pyrrhotite, also known as iron sulfide, ferrite, and columbite are natural magnets. There are three types of iron ores. They are hematite, which contains 69% of iron, magnetite, which contains 72.4% of iron, and siderite, which contains 48.2% of iron. Magnetite is an oxide ore of iron with the formula Fe3O4. Among all the ores, magnetite has more magnetic property. Artificial magnets are made by humans. Artificial magnets are of different shapes and are made of metals like iron, nickel, and cobalt. Artificial magnets are also known as man made magnets, which are stronger than the natural magnets. Artificial magnets generally have a strong power of attraction. Artificial magnets can be made in different shapes and they are made of metals like iron, nickel, and cobalt. Artificial magnets are produced from magnetic materials. Bar magnet, horseshoe magnet, U shaped magnet, cylindrical magnets, disc magnets, ring magnets, needle magnets, and electromagnets are some examples of artificial magnets. Alloy of the metals neodymium and samarium are used to make artificial magnets. Artificial magnets can be made with required and specific strength. The properties of artificial magnets are time bound. Artificial magnets have a wide usage in our day to day life. The scientist William Gilbert laid the foundation for magnetism. Gilbert suggested that the Earth has a giant Bohr magnet. William Gilbert was born on 24th May on 1544. He was the first man who performed the systematic research on the properties of the lodestone, which is the magnetic iron ore, and published his findings in the influential D Magnet or the magnet. The properties of a magnet can be explained as attractive property, reflective property, and directive property. Attractive property. A magnet always attracts materials like iron, cobalt, and nickel. To understand the attractive property of a magnet, let us do an experiment. Take some iron filings in a paper and place a magnet near them. Do you see the iron filings being attracted by the magnet? In which part of the magnet they are attracted? You can observe that the iron filings are attracted near the ends of the magnet. These ends are called poles of a magnet. This shows that the attractive property of a magnet is more at the poles. One pole of the magnet is called the north pole and the other pole is called the south pole. Magnetic poles always exist in pairs. What happens when a bar magnet is broken into two pieces? Each broken piece behaves like a separate bar magnet. When a magnet is split vertically, the length of the magnet is changed and each piece acts as a magnet. When a magnet is split horizontally, the length of the new pieces of magnet remains unchanged and there is no change in their polarity. In both cases, the strength of the magnet is reduced. Now, let us perform an activity to understand the repulsive property of a magnet. Take a bar magnet and suspend it from a support. Hold another bar magnet in your hand. Bring the north pole of this magnet close to the north pole of the suspended magnet. What do you see? The north pole of the suspended magnet will move away. This activity explains another property of a magnet, that like poles repel each other. That is, a north pole repels another north pole and a south pole repels another south pole. If you bring the south pole of the magnet close to the north pole of the suspended magnet, you can see that the south pole of the suspended magnet is immediately attracted. Thus, we can conclude that unlike poles of a magnet attract each other, that is, the north pole and the south pole of a magnet attract each other. Now, let us perform an activity to understand the directive property of a magnet. Suspend a bar magnet from a rigid support using a thread. Make sure that there are no magnetic substances placed near it. Gently disturb the suspended magnet. Wait for a moment. Let it oscillate. In a short time, it will come to rest. You can see that the north pole of the magnet is directed towards the geographic north. Repeat the procedure a number of times. You will observe that the magnet is always pointed in the same direction. This experiment shows that a freely suspended bar magnet always aligns itself in the north-south direction. The property of a magnet by which it aligns itself along the geographic north-south direction when it is freely suspended is known as the directive property of a magnet. The north pole of the magnet points towards the geographic north direction and the south pole of the magnet points towards the geographic south direction. Children, I hope that you might understood very well about classification of magnets and magnetic properties. Thank you for watching.